Hello guys, welcome back to my YouTube channel. So today we are going to solve day 14 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2064. Minimized maximum of products distributed to any store. Okay, so let's read the problem statement first. You are given an integer n indicating that there are n retail stores. Okay, so here n is equal to 6 simply means that there are 6 stores. 1 2 3 4 5 6. There are m product types of varying amounts which are given as a zero indexed integer array quantities where quantities of I represents the number of products of the ith product type. Okay, so let's say this is product type 0, this is product type 1. Okay, so for product type 0 we have 11 total products. For product type 1 we have total amount as 6. Okay, number of products. Okay, product type 1 has 6 quantity. Okay, product type 0 has 11 quantity. Okay, that's the simple meaning of this one. Okay, you need to distribute all products to the retail stores following these rules. A store can only be given at most one product type. Okay, so these are my stores, right? These are my stores, 6. Okay, so this is my store number, let's say 1. This is my store number 2. This is my store number 3. This is my store number 4. This is my store number 5, and this is my store number 6. Okay, so I can only distribute a unique product type to any store. Okay, a store can only be given at most one product type. Okay, so if here in this store I am giving product type 0, so I can't give product type 1 in that case. If I am giving product type 1 for store 2, then in the same store number 2 I can't give product type 0. Okay, that's the simple meaning of this line. Okay, and we can distribute any amount of that. Okay, if I am giving type 0 here, product type 0 here in this store 1, I can give any amount. I can give 1, I can give 2, I can give 11. Okay, but if I'm giving product type 0, then I can't add product type 1 here. Okay, in the same store. Okay, this is okay. Now after distribution, each store will have been given some number of products, possibly 0. Okay, so this may be case that I have distributed all the products to four total for okay, let's say there is only one element in this quantities array, that is 4, and we have n is equal to 6, so I have given 1 1 1, okay, to all the stores, and there are 2 stores which are still empty. Okay, so after distribution each store will have been given some number of products, possibly 0. Okay, that's possibly 0. Let x represent the maximum number of products given to any store. Okay, x is representing the maximum number of products that are given to any store, and we want this x to be as small as possible. Okay, you want to minimize the maximum number of products that are given to any store. Okay, we have to minimize the maximum number of products that are given to any store. Okay, and in the end we have to just return the minimum possible x. Okay, so now see this example number 1. Okay, but I hope that you guys are clear with the problem statement. Okay, so here total 6 stores we have. Okay, and we have two product types, product type 0 and product type 1. Product type 0 has quantity 11, product type 1 has quantity 6. Okay, so here let's say I have distributed this 11 to here. Okay, 3 here and 3 here and 3 here. Okay, like this I have distributed product type 0. Okay, so 2 plus 3 5, 5 plus 3 8, 8 plus 3 11. Okay, so now for this product type 1, okay, I can only add this here in store number 5 or store number 6. I can't add in any other store. And let's say I have distributed this 6 like this. Okay, 3 and 3. Okay, so this is the best case now. Okay, so in this best case you see that 3 is the answer. Okay, 3 is the maximum number of products that are given to any store, and we we tried to make it as low as possible, as minimum as possible, but there is no other possibility. I can't assign to all the stores. Okay, if I add to all the stores here, then until here I have covered. Okay, so if I try to add 2 to 2, so all the stores will be covered. Then where can I add this 6? Okay, I can't add product type 1 if I distribute them 2 to 2. Okay, so this is the best possible way to distribute the products. Okay, so I try to keep it minimum. Okay, so we have to minimize the maximum number of products that are given to any store. Okay, so this is the best case. So out of this what is maximum number? 3. So we are returning 3. Okay, the 11 products of type 0 are distributed to the first 4 stores in these amounts 2, 3, 3, 3. The 6 products of type 1 are distributed to other 2 stores in these amounts 3, 3. The maximum number of products given to any store is max of all this. Answer is 3. That's it. Okay, clear? Now see this example number 2. 7 stores we have. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and we are distributing like this. Okay, 5 here, 5 here, and 5 here. For this, 5 here and 5 here, and for this one, 5 here and 5 here. Okay, so best answer is going to be 5. Okay, there is no other possibility. I can't add 4, 4, 4, 4, then I will not get the best answer. So 5 is the best answer, so that is why 5. Okay, and here single store, so in the single store I am going to add all these. Okay, so the answer is this same thing. Okay, clear? Now okay, so now tell me this. Okay, so my n is equal to 2 and quantities arrays like this, 5 and 7. Tell me the answer of this one. Think about this. So the answer for this one is going to be 5. Okay, this is product type 0, product type 1. Okay, 2 stores I have. So in first store I have added uh answer is 6. Okay, answer is 6. Why 6? Oh no, sorry, answer is not 6, answer is 7 here. And why 7? Because product type 0 I have added here 5. So now I can't add this product here. Okay, so here only I have this option only left. Okay, so here I've added this 7, right? And here I've added 5. Okay, so I can't add like this 6, 6, right? So if I add 6, 6, so that simply means that 5 of product type 0 and 1 of product type 1, but this is not the case. Okay, this is not required. Okay, so in a single store I can only distribute a single product type. Okay, so that is why 5 come here. Then this is the only option left, so here I've added 7. Okay, so 7 is going to be the output. Okay, we have to return the maximum number of products that are given to any store. 7 is output. Okay, so now how we are going to solve this problem? Okay, so let's understand this with an example here. Okay, so let's say my n is equal to 6. Okay, and my quantities array is like this. Let's say 4 here, let's say 3 is there, let's say here 2, and here let me add 6. Okay, and here 2. Okay, so let's say this is the example. Okay, so now how I'm going to solve this problem. Okay, so here 6 stores we have. Okay, so 1, 2, 3, 4, 5, 6. Okay, these are nothing but stores. And if I want to give them indexing, so I can give index 0, 1, 2, 3, 4, 5. Okay, and clear? Okay, so now here first thing I'm just going to implement the binary search here. Okay, so what I'm trying to find here, I'm trying to find this number now. So let's say this is nothing but my x value. Okay, this is x value. So what I will do here, I will see that if, let's suppose if my x is equal to 3, then with this x is equal to 3, can I add all these elements in all these stores? Okay, with x is equal to 3, the answer is possible or not? Okay, so this is what I'm going to search. With x is equal to 4, answer is possible or not? With x is equal to 5, this answer is possible or not? Okay, so this is what I'm going to find. So with x is equal to 3, I was getting the best answer here, like this 2, 3, 3, 3, 3. Okay, so I'm going to assume this initially, that let's suppose 3 is the max number that I can give to any store. Okay, 3 is the max number that I can give to any store. This is what I'm going to assume initially. Okay, and then I'm going to try to fill the values. Okay, so here let's see what I'm going to do. Okay, so here for binary search we need two boundaries, one is left and right. Okay, so left, let's say my left is 0. Okay, so minimum amount that I'm giving to any store is 0. Okay, let's say. And right here, take this right as max of this quantities, so max value here is 6. Okay, so give here 6. Okay, so now we have to calculate the mid. Okay, mid is nothing but left plus right divided by 2. What we are going to get? 3. Okay, and binary search now, so we are going to run one while loop while my left is less than right. Okay, so inside this we are going to calculate the mid. Okay, and once we have calculated this mid, now we are going to check if we can distribute the products. Okay, like this. Okay, x is equal to 3, at most 3 products to all the stores. Okay, this is my requirement here. Let's see. Okay, 3 is the max that I can give to any store. Okay, and now let's see. So here 3 for 3 I'm checking first. Okay, 3 is the number that I got here. I for 3 I'm going to check. Okay, now see here, first is this 4. So this 4 is going to fit here? No, no, right? This 4 is not going to fit here completely, right? So what I'm going to do here, so my remaining is going to be only 3 I can fit. Okay, only 3 I can fit. So here the remaining is going to be 4 minus 3 is equal to 1. Okay, so here let's say this is product type 0, product type 1, product type 2, product type 3. Okay, so here I have added 3 of 3 of product type 0. Okay, so this 0 is just for your reference. Okay, I'm not going to write not going to write the code for this 0 part. Okay, this is just for your reference. So for product type 0 I have added 3 here. Now there is one remaining. Okay, so in the next store I'm going to add that remaining. Okay, 1 of product type 0. Okay, this is done. Okay, now I move to the next. This is clear. Okay, this is done. Product type 0 I have filled all these things in my stores. Okay, now this is done. Now I have to fill product type 1. Okay, product type 1, 3 here is completely fitting. Okay, so here I'm going to add 3 with product type 1. Okay, this is done. So I'm moving to the next store. Okay, because in the same store I can't store the different product types, right? So that is why I'm moving to the next store now. So here this 6, for this 6, 3 of product type 2 I am adding here, and remaining 3, so remaining 3 I'm going to add here, 3 of product type 2. Okay, this is done. Now here 2 I can add 2 of product type 3. Okay, so with this I'm getting the best result. Okay, I'm getting the result. Okay, simple say I'm getting the result. Okay, so here with 3 I know that result is possible. Okay, this is what I know. Now is this the right answer? Okay, there may be some other best case. So what I'm going to do, with 3 answer is there. Okay, so now after that we are going to check for the numbers which are less than 3, right? That is the only thing that we need to check. So what I'm going to do, what we do in the our binary search, we are going to change our right to mid. Okay, and then again we are going to now my left is still 0, my right becomes mid. Okay, now we have to, inside that we have to calculate the mid again. Okay, mid is going to be left plus right divided by 2. 0 plus right is, here right is 3 na, 3, mid was 3, so right is becomes 3. So 0 plus 3 divided by 2, what is going to I'm going to get is 1. Okay, this is 3, 3 divided by 2, 1. Okay, so now with the 1 I'm going to check. Okay, and here this L is 0 and L is 0 and R is 3. Okay, so this is possible right now, so I'm still checking. I am still checking. Okay, so with 1 I will check the possibility. Okay, so here with the 1 we can't distribute, right? It's clear now. So if here I have added all that products 1 1 1 for product type 0 first. Okay, 0 0, so it is not possible. Okay, and then for 3 I am adding 1 here for product type 1, 1 here for product type 1, then all other are remaining, 1 of this one and 6 2 are remaining. Okay, so with 1 I'm not going to get the best answer. Okay, with 1 I'm not getting the best answer. So now what we do here, then in our this binary tree. Okay, if the result is not possible, then we are going to increase the minimum possible maximum. Okay, so with the 3 answer is possible. with one answer is not possible. Now what? Now I'm just going to increment my left to mid plus 1. Okay, that's what we know do, right? So mid is 1 plus 1 is 2. Okay, so this is going to my become my left is equal to middle plus 1. This is what I did here. Okay, and the right, what was my right? My right was from last time, my right was 3. Okay, right was 3 only. Okay, so right was 3. All right, so now l l is less than r. Okay, so this condition is satisfied. So again, let's do that mid. Let's calculate the mid. 2 plus 3 divided by 2, 5 divided by 2, I will get 2. Okay, with 2 I will check the possibility with 2. So 2 products, still it's not feasible, right? 2 of product type 0 I have added here, 2 of product type 0 I have added here. Then for this 3, 2 of product type 1 first I added, then okay, then again 1 of product type 1. Okay, so this is there. Now 6, 2 of product type 2, 2 of product type 2. So now still here 2 of this one and 2 of this one are pending. Okay, total 4 are still pending. So with the 2 also result is not possible. So if result is not possible, then what we do? We increment the left. Okay, left is equal to mid plus 1. Left is equal to mid plus 1. So mid from last time was 2, so 2 plus 1 is equal to 3. So left becomes 3 and my right from the last time is 3. Okay, so now I'm going to exit. Okay, now I'm going to exit. Both L and R are 3, so I'm going to exit of this while loop, and in the end I'm just going to simply return my left. So what was my left? So my left was 3, so I'm just going to return 3. 3 is nothing but my best answer. That's it. Easy. Okay, so now with code you guys will get much better understanding, but I think I know that you guys are already clear, okay, with this explanation. Okay, so now I'm going to write the code. Okay, code is going to be very simple. Okay, simple binary search that we need to do here. Okay, so here first thing, take left and right. Okay, so here first we are going to initialize the boundaries of binary search. Okay, so here I'm just going to write int left is equal to 0 and right is equal to let's, I'm writing 0, but it should be maximum quantity. Okay, so let me update the value of right. So I'm just going to iterate over all the quantities one by one. Quantity in my quantities. Okay, and here right is right, right is equal to math dot max of my right or current quantity. Okay, so that's what we need to do. Okay, so now I have updated my right. All right, this is done. Okay, so now we have to perform the binary search until the boundaries coverage. Okay, so simple binary search while my left is less than right. Okay, and inside this we have to calculate the middle. How we are going to calculate the middle? Is equal to left plus right divided by 2. Okay, this is done. Then after that we have to check if we can distribute with that particular middle. Okay, this is what I was checking, right? First we get the middle as 3 in the last example that we have covered. So with the 3 I will check if we can cover. Okay, we can cover all the products and stores, right? All the products mainly. Okay, so here if can distribute, let's write this function distribute. And how I'm distributing? I'm distributing by by saying that it should not be greater than my middle. Okay, the value in quantity in particular store. Okay, and in this can distribute, let's pass my quantities array because I'm going to use that quantities. Okay, spelling is correct, right? And here I'm going to pass n. Okay, n is nothing but my number of stores. All right, now here if we can distribute, then what we were doing, we were trying for a smaller maximum. Okay, so in that case, if result is possible, what I was doing, I was just changing my right to middle. And if the result was not possible, then what I was doing, I was just incrementing my left to middle plus 1. Okay, we have to then increase the minimum possible maximum. Okay, so left is equal to middle plus 1. Okay, so here let me add the comment now. Increase the minimum possible maximum. Okay, and here what we are doing, we are doing try for a smaller maximum. Okay, and in the end here we have to simply turn left. That's it. Okay, that's what we need to do. Now this is the remaining part, can distribute. Okay, so let me write the code for this one as well. Okay, so this is also going to be very simple. Whatever I explained, I am just going to do the same thing. Okay, so this is going to be boolean type. Okay, so public boolean can distribute, and inside this just pass x. Okay, and quantities. Can I do one thing? Can I just copy it from here? Int quantities and int n. Okay, this is done. Now inside this first point to the first not fully distributed product type. So it is going, let's say int j is equal to 0 initially, int j is equal to 0, and the remaining quantity of the jth product type. So here int remaining. So we didn't fill anything else, anything right now. Okay, remainij remaining is equal to quantities of j. Okay, quantities of 0. So first product type will be picked here. Okay, then we are going to loop through each store. Loop loop through each store. Okay, and now for int I is equal to 0, I is less than n, I plus plus. Okay, and we have to check if the remaining quantity of the jth product type can be fully distributed to the ith store. Okay, so how we are going to check? If remaining is less than equal to x, then that simply means that it's possible. If yes, then we are just going to move the pointer to the next product type. Okay, so j plus plus, j is just represent a product types indexing, right? And we have to check if all the products have been distributed. So here I'm just going to check if all the products have been distributed. That simply means if my j is equal to quantities dot length. Okay, so that simply means return true. Okay, if all the products are distributed. Else, okay, if they are not distributed, since we have already incremented the j previously, so we know the remaining of the next product type. So remaining of the next product type is going to be here quantities of j. Okay, this is done, right? And here one more thing, if we can't distribute. Okay, if we can't distribute, so if there are 4 and we are checking for 3, so 1 is remaining now. So here I'm just going to update the remaining as you can say remaining as remaining minus write it like this now, minus equal to x. Okay, because x is the maximum that I can distribute to any store. Okay, and in the end here if we didn't return true anywhere, so just simply return false. Okay, so that's it. Now let's try to run the code and see if there are any code issues. All right, so here middle plus 1, right, is equal to middle. Let's run it again. Okay, line number 33. Oh, okay, didn't add that. If remaining, now definitely spelling mistake I'm doing. If okay, e should come. I should use smaller variables. Okay, so now all the test cases has been accepted. Okay, and here let me create one more test case, n is equal to 2, and here 5 and 7, and let me create one more test case, n is equal to, let's say 6, and the values, let's say 4362, 4362. Okay, so now let me run it. So for this we are getting 7. So here I have explained that. Okay, so for this we are getting 7. Okay, and for this we are going to get 3. Okay, clear. Now let's submit it. So see, all the test cases has been accepted. Now time complexity. Okay, so see here, uh, for binary search, boundary is 0 to the max value of my right. Okay, so here for this binary search I'm going to say that my time complexity is going to be of log of max value of quantity. Okay, so here you can simply say time complexity for binary search is going to be of log of max value of my quantity. Okay, so this is for binary search, and here we are just going to iterate over all the quantities one by one. So here you can say of quantity. Okay, and here inside this we are also calling this can distribute. So can distribute is basically iterating over all the products. Okay, so if we distribute all the products we are stopping. Okay, so it depends on the products total quantities length. Okay, the number of quantities that we have. Okay, so here j is equal to 0. Now if j becomes quantity of dot length, we are just simply turning true. Okay, so it basically depends upon this quantities dot length. Okay, so for this can distribute function I can say it is going to take of a complexity of my quantities dot length. Okay, basically it is depending on this one only, quantity dot length. Okay, so overall time complexity you can say that. Okay, so here max of quantity, let's say I'm saying this variable as k. Okay, k is nothing but max of quantity. Okay, let's say this, and quantity dot length here I'm saying of n. Okay, so here for this main part, okay, overall time complexity is I'm going to say is of n into log k. Okay, log k this and this. Okay, and yeah, basically it is going to dominate by this step. Okay, so let's see what is the time complexity showing here. So yeah, of n log m or n log k, you can say anything. Okay, so that's my time complexity. Okay, so I hope that you guys are able to understand today's problem. If you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.